Hey everyone, Geek37 back with another video, and this is part 30 in my Exploring the Heptagonal Triangle series. And what we're going to do is we're going to do what looks like quite a complicated calculation. We're going to find the value for this identity, sine squared pi over 7 times sine squared of 2 pi over 7 plus sine squared of pi over 7 times sine squared of 4 pi over 7 plus sine squared of 2 pi over 7 times sine squared of 4 pi over 7, and that does come out to be a nice fraction. Now what we're going to do is we're going to use the identity that I've used in a couple of other videos where we take three values, add them up, and square them, and we get x squared plus y squared plus z squared times, or plus 2 times the quantity xy plus yz plus zx. We're going to do something similar with that. And what it's going to be is we're going to use sine squared of pi over 7 plus sine squared of 2 pi over 7 plus sine squared of 4 pi over 7. That will equal sine to the fourth of pi over 7 plus sine to the fourth of 2 pi over 7 plus sine to the fourth of 4 pi over 7 plus 2 times what we have written above. Let me write that out one more time. It's a bit of a tedious to do that. Oops, 2. Now, if you look at the way I wrote the expression, I wrote it like above, but I'm saying it's equal. We've used that identity. The thing is I have the two terms in those parentheses switched around. If I did it correctly, it should be sine squared 2 pi over 7 times sine squared of 4 pi over 7, and then the third term, sine squared of 4 pi over 7 times sine squared of pi over 7. But with the way that multiplication and addition work with the commutative property, that expression that I just mentioned and what I wrote are the same. Now here's what I'm going to do just to make this a little easier to read, because this is what I would call a pretty heavy writing expression. This part here that I have that is in orange, I'm going to label as S sub 1. So S sub 1 is the sum of the fourth power signs, and if we remember, I proved this in a prior video that was equal to 21 over 16. Now I'm also going to do an S2, and let me mark that in this magenta, purple, pink color here. We'll make that equal to S sub 2. And if you remember in another prior video, the sum of those sine squareds would equal 7 over 4. And what I'm going to do with this part here that I'm going to do in highlighted yellow, I'm going to call this M because it's a pretty messy looking expression. So I'm just going to call that guy M. So now we've got this complicated looking expression knocked down to a pretty straightforward linear equation. S sub 2 equals S sub 1 plus 2 times M. Let's plug in our values. So S sub 2 is 21, or S sub 1 is 21 over 16. And S sub 2, that should be quantity squared, my bad. So that would be 7 over 4 squared, just like so there, equals 2m. 7 times 7 is 49, and 4 times 4 is 16, so this fraction becomes 49 over 16 equals 21 over 16 plus 2 times m. Going up here, we subtract the 21 over 16 from both sides. We'll get 28 over 16. equals 2m. We can divide both sides by 2, which is the same as multiplying by 1/2. The 2 and the 28 cancel, so we're left with 4 over 16, or excuse me, 14 over 16. And that will reduce down to 7/8 because 14 and 16 are both even. So the sum of this weird identity works itself down to be 7/8. Okay, this particular identity, I titled it as a sum of or a series of sines. The sum, a series of never mind. It's a bunch of sines being multiplied and added together after the sines have been squared, and we got that value of 7/8. I find that quite fascinating. I found this on the Math World page for the heptagonal triangle. It's one of those identities that that pops up that uh, is quite interesting to solve, and I wanted to show it to you today. All right, I hope you enjoyed this video. I enjoyed making it. This is Geek37 signing off.